Hello students and welcome back to the course Cybersecurity Training by MindMajix. What is TCP and UDP protocols? What is a three-way handshake? What is ping? What is OSI model? These are some very important topics when it comes to VAPT or cybersecurity experts. The very first question I wrote here is what is Nmap? You can consider Nmap being James Bond for what we say VAPT experts. It's like something you could just throw on someone and it would work perfectly fine for you, and you will need it in every phase of your cybersecurity career, each and every phase. It is a community tool. You can easily get it from the internet. You can get it from Windows itself. It is available in different programming languages like Python. So the very first question I wrote here about is what is TCP and UDP protocols. You know, see, when two devices have to communicate between them. For example, there are two devices. I will annotate it a little. I don't prefer doing this. See, here is two devices here. You have to just simply what we say make them talk from here to here, and then this way back they could communicate between them. But the question is, there are thousands of or like crores of more devices available. What happens if the data doesn't go like this way? It doesn't go in this manner. Okay, it just goes here. No one knows where it goes. Okay, it can go here, it can go here, or maybe this could go directly here. Don't know where to do these things. Okay, that's why the topic came TCP protocol. I'll just turn off the annotate. So TCP is a connection oriented protocol and UDP is a connection less protocol. What it means, TCP is like you can say when an Amazon guy comes to your home to deliver something, he asks for OTP that is in your app itself. You just provide them OTP. He asks your name, and then after verification, he gives you the order, the product, and you take it home. But in case of UDP, it's like you are going to some like place where people are organizing a party. Okay? There you don't need to verify yourself. You just go there, eat, and come back. UDP is same like that. A little difference is that UDP throws out the data without like knowing that the data is reaching the destination or not. It will just keep on sending its data without any verification whether it is receiving any data, the destination is receiving any data or not. In case of TCP, it verifies. If the data isn't transferred, it will make sure that the data is retransmitted and is received from the receiver end. And no redundant data is copied on the receiver end. That too is mandatory. Yes, the speed of TCP is very slow than UDP because, as I told you, TCP verifies the data has received by the receiver or not, but UDP doesn't. UDP just throws the data out, whether you receive or not, I don't care. Then comes TCP handshakes. What is that? TCP follows a handshake protocoling method. Like it will send SYN packet, it will receive back SYN ACK, it will send ACK. I'll discuss it within a few seconds after this slide. But UDP doesn't follow any kind of protocol of handshakes. That's why it doesn't verify whether the data has been delivered or not. The same thing has been written in the last line also, that TCP has acknowledgement segments, but UDP does not. Before going to any next slide, these things, I'll just go on this tab which I opened for you. I'll share these three images I'm going to discuss in the very next moments on your like resources section. Go fetch it from there. Make sure you go through it once. See, the communication is always made between client and server. Okay, client and server refers to the guy or the system which requests a data is the client, and the one who sends the information or resource is the server. So here the client is trying to establish a connection with the server. It will send a SYN packet. SYN here stands for synchronization. Okay, it sends a synchronization packet to server. If server agrees to connect, server will send synchronization with acknowledgement. That is, that it has acknowledged this synchronization packet it has received, and it will send the synchronization packet back to client, just in order to make sure they are synchronized on the same time. Finally, client will send the acknowledgement packet. Server know that it has applied its synchronization packet in it, and their connection has been successfully established. State change to established. This is very important. I have told you it very short. I'll later on maybe I'll be covering it too deep, but I'll recommend you go through it once. What this sequence stands for, what this acknowledgement stands for, why is it 200 and it is 201, why it is 101 and why it is 100 here. I'll tell you all this in upcoming lectures, and we'll go deeply into networking portion. All this belongs to networking portion, but before knowing Nmap, we should know this. So this is the definition of the OSI model. Okay, the very next thing is ping and OSI model. I'll discuss OSI model first, then I'll come to the ping so that you could understand it more easily. See, physical layer is something where the real action comes. You can see the wires, the bit is flowing through that wire. Physical layer is itself is telling you that it is somewhere you can physically observe the change. Okay, actually you don't observe the physical change, but yes, it is termed as because bit of stream is flowing from one place to another. It will flow through some medium. Okay, so that medium can be like observed and told that the data is being traveled. Then comes data link layer. It is the layer which formats the data on the network, how the data has to be looking on the network itself. Then comes the network layer. It will decide which path the data will travel or the data packet will travel to reach its destination. For example, there are four devices in mid, four hops A, B, C, D, E. A to E he has to reach, and there are B, C, D in mid. Whether it will go A, B, C, E, or it will go A, B, C, D, E, or whether it will go A, C, D, E, or A, E, D. Okay, it depends on it. On the network layer, it will decide where to go and where not to go. Then comes transport layer. It is responsible for the like TCP and UDP protocol transmissions that I told you in the last one to make the connections. Okay. If it is UDP, it will simply throw the packet. If it is TCP, it will acknowledge it and make sure that the data has been received by the receiver. Then comes session layer. Session layer maintains the established sessions and ports that has been enabled to transfer the files or anything or data packet with the server or client. Then comes the presentation layer. This layer is responsible for data encryption. Data encryption is something like you can say in aptitudes we used to learn how to write if sun is written as moon, then what would be the moon written as, something like that. I'll discuss it with you. There are some algorithms which will be needed to discuss RSA, MD5, and all these algorithms. You will need to know AES, DES. So, and what is data compression and what is data expansion. So, this would be in this itself extraction of data. Then comes the application layer. This is the layer where human and computer interaction happens. What here I means is if you do like any change to an application, for example, you post your photograph on the Facebook, you post it through the Facebook app. That Facebook app is the part of application layer itself where you interact with that application to make some changes, and it will go through like other layers and do its work from one device to another. For your knowledge, I'm telling that this layer OSI model, 7 layer model, is never used in this industry because it takes a lot of time from traveling from one point to another. The TCP IP suite is followed, which we will be discussing in the next lecture. And coming on the very last photograph that I opened in. So there are some protocols and some short explanations of what they are called in that particular layer. In application layer, the data is called end user layer, and there are HTTP, FTP, IRC, SSH, and DNS protocols. Make sure you go through this. I won't be able to explain it right now because it would take a lot of time, and we have to just jump onto the Nmap. So just go through this once. Make sure you go through protocols once each. What is HTTP, what is FTP, and what is SSL, what is SSH. Just go through their definition and basic means. Don't worry, we'll later on discuss about it quite aggressively. Aggressively I mentioned because of the Nmap. I'll tell you why I did so. Okay, so what is ping? Simply saying someone a hello and the response coming from their hello. What do you understand by this? It is like, oh hello. The other guy says, oh hello. So this is an interaction between two devices or two people or two like assets. Okay. The ping acts the same way. It sends a ICMP packet to someone, and if it like accepts, the result will be given to you, and if it doesn't, the packet will be lost. Ping is very important command in like this field. I'll tell you why. You don't have much time. Sometimes you have to check whether the host is up or the host is shut down. You will just ping it, and you will come to know whether the host is like doing something or it is in the sleep mode. So ping takes the least time to do this. Nmap also uses the ping scan. I'll tell you how, and it also uses a no ping scan. There are a lot of like stuff in Nmap we will be discussing.